Howdy, everybody. I'm Jim Pettigrew. I'm the board director for the GRP's Gulf Offshore Energy Safety Board. And I'm very excited to welcome you here today to the inaugural event in a new colloquial series on offshore energy. And this is a partnership between the Gulf Research Program and the National Academy of Engineering. This partnership leverages the GRP's mandate and the National Academy of Engineering's capabilities in systems engineering. Ultimately, these events will combine the knowledge of those involved in offshore energy to advance safer energy production in the offshore environment and maintain the Gulf of Mexico as a major provider of US energy. As a reminder, we'll be recording today's discussions in order to post them for later viewings. But we do ask you to participate as we go through today. Next slide. We will take questions and answers via the Q&A box at the bottom of your screen. We will have a moderated question and answer period after Secretary Winter's remarks. We look forward to sparking new interest in applications for and connections among leaders in the energy industry as the GRP serves as a functional vehicle to realize positive impact and transformative change in a rapidly changing energy industry. I'm now honored to introduce Dr. John Anderson, the President of the National Academy of Engineering, and Dr. Lauren Alexander Augustine, the Executive Director of the Gulf Research Program, to provide their welcomes. John?
Thank you, Jim, for your introduction, and I thank all of you for joining us for the inaugural colloquium of our offshore energy series. My name is John Anderson, and I am the President of the National Academy of Engineering. The NAE enthusiastically partners with the Gulf Research Program to address issues related to offshore energy production and transportation safety. Reducing systemic risk offshore is directly related to several of the NAE's grand challenges for engineering, which were identified in 2008 as critical game-changing goals for improving life on the planet in the 21st century. For example, the grand challenge of advancing health informatics could provide a step change in how offshore crews are managed and kept safe by giving real-time data regarding the state of health of the workforce. In addition, the grand challenges of advancing personalized learning could have great impact on the learning experience of offshore workers by developing personalized techniques that help determine and modify an individual's continuous learning efforts. Finally, the grand challenge to engineer the tools of scientific discovery expands the capabilities of undersea technology used by the oil and gas industry. These are just a few of the ways that the NAE's grand challenges intersect with the critical issues of offshore energy safety. As we launch today's inaugural NAE-GRP Colloquium, the National Academy of Engineering extends a warm welcome to Secretary Don Winter, who is the chair of the National Academy of Engineering. We are grateful for the opportunity to learn about critical lessons in offshore energy and excited to hear from experts. This colloquium series continues. It's now my pleasure to hand the microphone over to Lauren Alexander Augustine, Executive Director of the Gulf Research Program, to speak on behalf of the GRP. Lauren?
Thank you, John. And thank you, Jim, and thank you, Secretary Winter. I'm very excited to be here. I am Lauren Alexander Augustine, the Executive Director of the Gulf Research Program. On behalf of the GRP, I want to thank everyone who's joining us today, all 100 of you here today. And we are delighted to partner with the National Academy of Engineering to identify novel and innovative solutions to the challenges in the offshore energy safety industry. Offshore energy safety is a topic of critical importance that requires collaboration and trust across industry, regulators, academic researchers, and broader stakeholder communities. Our work at the GRP, at the Gulf Research Program, brings together and we convene such stakeholders in order to contribute to the reduction of systemic risk in offshore energy activities. Offshore energy also requires enormous engineering feats, and some of the equipment is nothing short of engineering marvels. And so it's for that reason that this colloquial series is super exciting for the GRP and NAE. It provides us the opportunity to highlight priority areas of common interest across industry, government, and research. Through this approach of talking through and identifying novel issues, we hope to spur new activity, develop new projects, and establish new collaborations that we can do together as we work towards our common goal of enhanced offshore energy safety. Today, we are just honored, absolutely delighted to host Secretary Don Winter as our inaugural speaker in this series. We look forward to benefiting from his wealth of experience and knowledge in this area and hearing more about implementing lessons learned in the offshore energy. So Captain Pettigrew, I hand it back to you, and off we go with Secretary Winter.
Thank you, Lauren. Thank you, John. I appreciate those comments of introduction. It is now my honor to introduce our speaker today, the Honorable Donald Winter, Dr. Donald Winter, who is a member of the National Academy of Engineering. He was the 74th Secretary of the Navy, and I was honored to serve on active duty under his guidance. He's the chair of the NAE Council. He was also the chair of the National Academy's Committee on the Analysis and Causes of the Deepwater Horizon Explosion, Fire, and Oil Spill. And Dr. Winter will provide a presentation and discussion, and we will have a follow-on question and answer period that will be moderated by Dr. Al Romig. Al is the executive officer of the National Academy of Engineering. So, Secretary Winter, I turn it over to you. And again, thank you so much for the gift of your time today, sir. And we look forward to hearing your thoughts and priorities as we move forward.
Well, Jim, thank you very much for the introduction. I'm pleased to be able to recap some of my experiences and thoughts regarding safety in general and offshore safety in particular. I have to tell you that unfortunately I've had more than a modicum of involvement in major safety issues, a number of fatalities that occurred during my watch as Secretary of the Navy. And I will stipulate that those represent, quite frankly, the worst experiences of that time. After coming out of the Pentagon, in the occurrence of Deepwater Horizon, the blowout, I was not surprised, quite frankly, to be asked by Chuck Vest, who was NAE president at the time, to lead the evaluation in support of the Secretary of Interior. One of the things that I've been doing since then is to try to provide a perspective on the Macondo Deepwater Horizon incident for, quite frankly, a fairly broad range of audiences. And one of the things that I found helpful is to really try to put Macondo into the context of other significant safety incidences that have occurred that we've tried to learn from. Because what I've found is that as difficult as it is to try to learn from these incidents, we often forget about that learning and recreate those accidents. And I'll try to explain what I mean by all of that. If I could have the first chart. Just as a top level introduction, I'm going to talk about a number of different safety accidents in very different domains. But hopefully you'll understand that there's some common elements there that underlie all of these. These are all major incidents that are deemed to be low probability, but very high consequence events. And oh, by the way, one of the things that we find invariably is that when you're dealing with complex systems, like an offshore oil well or some of the other systems we'll talk about, that the failures tend to be fairly complex. They're not simple one error type failures. And establishing the causation is equally difficult. We try to separate those factors into what's considered to be direct or proximate causes, those causes that contribute, and in particular, systemic factors that create the environment that enables these events to occur. Now, one of the things that we see invariably after a major event is a call for an investigation. And often these calls are motivated by political considerations and a desire to establish who should be held responsible, the cause, the culpability, and the liability for these events. These are challenging investigations because, quite frankly, causation is often in the eye of the beholder. What one person views as a major factor in a failure might be minor in the view of others. And one of the other things that we found, unfortunately, is that trying to establish culpability and liability often interferes with findings of facts and determination of cause. I remember quite vividly that right before one of the Coast Guard hearings associated with the Macondo incident, Department of Justice announced that they were coming down to New Orleans to establish who should be put in jail for the incident. And I will just note that the next day, many of those individuals who had agreed to testify and to help us understand what had caused Macondo to blow, all of a sudden took the Fifth Amendment and declined to participate and support the investigations. If I could have the next chart, please. One of the other things that we find is that, and again, this is a general consideration, is that everyone wants to know what the cause is. And everyone is hoping, praying, if you will, that they can identify one single item that created the problem and be able to fix that one item to be able to restart activities. In the case of Macondo, I was told by a number of individuals that obviously, in their mind, obviously, the blowout preventer had been misspecified and a higher pressure BOP was obviously needed. And once we corrected that for this area, all would be well and we could restart drilling. Not quite the case. There's a lot of factors in here. There's human psychology issues. There's that desire to get that rapid fix. And oh, by the way, it would be a hell of a lot easier to assign culpability and liability if we can identify one specific cause. What we found in the case of Macondo, but what we find, I would suggest in general, is that the investigations that prove to be most productive are those that address a very wide range of causes to try to establish what went wrong and to identify what corrective actions are needed. And I will just say that getting that full range of corrective actions implemented is almost invariably a struggle. And maintaining that corrective actions proves to be even more difficult. If I could have the next chart, please. We rarely see a full spectrum of recommended changes implemented. For one reason, if nothing else, there are significant consequences associated with those recommendations. Economic considerations, the cost, political considerations in many cases. And also, it's very difficult to get people to fully understand the implications of what we tend to refer to as the systemic factors, those factors that affect the culture, and I'll say a lot more about culture later on, that enable these events to occur. Invariably, though, even to the extent that we do make changes, we find that the lessons often fade with time for multiple reasons. First of all, memories fade. It's no longer vividly in someone's memory. They don't see that occurring in front of their eyes. They don't see the TV images anymore. And this is especially true when you have cases that do not include fatalities. People change. Personnel are changed time and time again, and pretty soon you have few, if any, of the individuals that were responsible or involved in previous incidents involved in the overall rulemaking and oversight of these activities. I've also heard a number of people argue that, gee whiz, we don't need to worry about much of this anymore because we've adopted very different technologies nowadays. And those technology changes really obviate the issues and the conclusions that were raised from the previous incident. I will suggest that sometimes that perception is very much misplaced. We have competing priorities all the time. I think one of the case studies that I will not talk about today has to do with the space shuttle incidents. And there we heard about, in terms of Columbia, the need for faster, better, and cheaper capabilities for space launch. Those are competing priorities with safety. You can have perhaps any two of those three, but you can't have them all without affecting safety. Lastly, I'll just suggest that one of the words I've learned to use quite often after this experience has been hubris. Hubris builds. Hubris builds with experience, and human perception often differs from proper mathematical analyses and systemic statistical assessments. Hubris is in part the result of people's desire to believe that they've overcome such issues and that they're seeing safe operations. Often this is greatly misplaced. Could I have the next chart, please? So today I will talk first of all about three case studies, very different domains. I'm going to talk about commercial aircraft cargo doors, go back to the original DC-10 incidents, and then later on to the 747 incidents. That's a span of roughly a few decades there. I'll go to the passenger ships and compare Titanic and Costa Concordia, span of roughly 100 years, and clearly very different technologies, but some very unfortunate repeats of previous incidents and previous issues that were felt to be corrected. And lastly, I'll talk about two blowouts, Montera and Macondo. For those of you not familiar, Montera was a blowout that occurred in the Timor Sea off of Australia just before Macondo, and could have been a good lesson for the operators of Macondo, but was not. One of the conclusions that I hope to get to during this discussion today is the value of a safety culture. Safety cultures are critical. They are, in my experience, the only way to really ensure that lessons are properly learned and implemented. They work in a variety of domains. I'll talk in particular to how it works within the Navy's submarine community. But I will also talk about the dangers of becoming complacent with regard to culture and the need to be able to reinvest on a continuing basis to ensure that the culture remains that which is needed. If I could have the next chart, the first one on the studies, talk about the two incidents with aircraft doors. These are both DC-10 incidents. The first one, American 96, occurred in June of '72. What happened here was, as the pilot was gaining altitude at just shy of 12,000 feet, he had a cargo door failure. The cargo door blew out. The result of that was that the cabin floor was depressed, and some of the control cables that he was using were damaged. The net result of it was basically the loss of his number 2 engine, the center engine, and the rudder. It was, I will say, a heroic effort by the pilot in command that saved the plane and all the passengers on board. This should have been a warning to the DC-10 community and aviation in general. It was what we sometimes refer to as a near miss that presaged future failures. Unfortunately, that failure was found less than 2 years later with Turkish 981. Not all that different in terms of the cargo door failing at around 12,000 feet. This time it was a little bit higher in altitude. In this particular case, as opposed to the cabin floor just being damaged, it collapsed and it severed enough of the control cables that the pilot in command was not able to save the aircraft. The net result was 346 passengers and crew were killed. Another case of significant loss of life due to, in part, a failure to learn from the previous experience. Now, there were opportunities to learn here within the DC-10 community. There were also opportunities to learn with regard to other aircraft, and I'll talk about the 747 on the next chart, if I could, please. As similar circumstances with 747s. March of '87, pilot realized as he was gaining altitude that he was unable to maintain the cabin pressure. He did return to the airport. They did find that the cargo door was not properly latched, and that was the result. That was the cause of the difficulty with the cabin pressure. Now, the issues with that cargo door should have been a red flag, if you will, an opportunity to learn from this near miss. But unfortunately, again, just about 2 years later, we had a much more severe failure with United 811. In this particular case, the forward lower cargo door just blew open. The explosive decompression literally ejected 9 passengers, and there was severe damage to the number 3 and number 4 engines. The pilot was able to, again, return the plane to the airport, but as is obvious, this was an incident with significant loss of life. If I could have the next chart. Just a general set of commentary regarding these 4 incidents, 2 of which were fatal. That both of those fatal incidents were preceded by near misses. There were opportunities to learn. There were common elements of design. I won't go into the details of these, but this is now pretty well known and recognized in terms of what needs to be done to ensure that cargo doors do not come undone, do not have explosive losses at altitude. Unfortunately, what we find is that after the 2 near misses, all the focus was on the ground operations and maintenance. It was a lot easier, I will suggest, to find the operations and maintenance personnel guilty of causing the incidents than it was to focus on the more systemic issues associated with the aircraft design. As a result, there really were no material design changes until we got to the point of fatal incidents. And as should be evident, there was no apparent learning going from the DC-10 to the 747. Obviously, different manufacturers, but it's the same community that's involved. If I could switch over here, get a little bit closer to Macondo, talking about passenger ships on the next chart. Titanic and Costa Concordia. Titanic, I think everyone knows, now 109 years ago. great loss of life. Everyone believes that we fixed all of these problems, right? What were the problems? First of all, it was going too fast given the circumstances that the captain found himself in. There were known icebergs in the area, and he was going too fast to be able to control for the last minute visibility of those icebergs. There were problems with what we call the naval architecture, the design of the vessel. In this particular case, it had to do with the design of the watertight compartments and the ability to deal with an extended opening below the waterline. We've talked a lot about the inadequacy of the lifeboats, the fact that there were number of seats was just a little bit more than half of the individuals that were on board. By the way, I will assert that if you go and take a look at the way lifeboats were used in this time period, there really were enough lifeboats. It clearly met all of the requirements. Lifeboats were not deemed to be areas or were not deemed to be usable for long-term saving of lives. They were intended to be able to move people between a ship in distress and a rescue vessel. That rescue vessel would be able to provide its lifeboats in addition, and they would go back and forth moving the people. This was an incident of a magnitude that had not been really perceived or expected. Last of all, there were no lifeboat drills, another factor underscored on many of these stories. Net 1,500 lives were lost on that event. Go fast forward just shy of 100 years ago, and we talk about Costa Concordia. For those of you who may not remember this, it's only about 9 years ago. What was wrong? Well, first of all, they were going too fast for the conditions. They were going very close to Giglio Island. I don't want to go into all the reasons why they were going in there. It was obviously a very bad decision, both in terms of how close they were going and the speed. There were issues with the naval architecture. In this particular case, the design that had all of the diesel generators located right along the keel. This was deemed to be an appropriate reaction to the need for high stability. But it also meant that once that area flooded, the vessel lost all electric power and was not able to steer clear of additional dangers. Lastly, we have problems with the lifeboats. There really weren't enough lifeboats. Yes, there was a lifeboat seat for everybody on board, but when you take a look at the fact that it took 1 hour for the captain to determine that one should abandon ship, and the fact that the ship was listing over at the side, which meant that half of the lifeboats could not be loaded, there was a significant problem. Other issues as well with the limited mobility of many of the passengers. One other factor associated with the lifeboats, current standards, IMO standards, International Maritime Organization, lifeboat drills are required within 24 hours of embarkation. 600 passengers have been on board less than 24 hours and had never participated in a lifeboat drill. Net, we had 32 lives lost. If I can have the next chart, a little recap. The Titanic led to one of the most intensive reevaluations of maritime shipping we've ever had, a whole series of conventions that are currently being updated. Everyone believes that they fixed the flaws and the issues, but one thing I think needs to be recognized. Ships, and this is also true of offshore activities, are always at risk to the vagaries of human behavior. No one knows what a captain is going to do, whether he might elect to go at a high speed, even if the conditions warrant otherwise. Also dealing with the requirements of the cruise industry and the desire for outside staterooms and shallow drafts and stability issues needed to keep people from becoming seasick. I won't go into those issues in any detail here, but those of you have a maritime background, I'm sure, understand much of that. And oh, by the way, the adequacy of the lifeboats are still an issue. As I noted before, list and trim limits create issues there. The assumptions of what a reasonable passenger weighs, quite frankly, is no longer appropriate. Something that needs to be revisited every once in a while. And by the way, the FAA is revisiting that in a similar manner right now. A number of considerable issues there, all maintained, forgotten, lessons learned, not currently being implemented. If I could have the next chart. Oh, by the way, for those of you who are not aware of it, Macondo was preceded by Montara less than a year before. Montara occurred in the Timor Sea off of Australia, off the Northern Territory. And guess what? The blowout occurred while it was being prepared for temporary abandonment. And the blowout was preceded by a failed pressure test of the concrete. Fortunately, no one was killed in this particular incident, but the flow ran unabated for 74 days before it was brought under control. A very significant incident, an opportunity for learning. Just compare it to what occurred at Macondo. Blowout during preparation for temporary abandonment. Blowout preceded by failed pressure test of concrete. But in this particular case, 11 were killed. I could have the next chart. I will stipulate that Montara was just one of a number of offshore safety events, blowouts and other safety accidents that could have been provided, lessons learned that might have prevented Macondo. One of the things I found to be fascinating was reading the minutes of a Senate hearing that occurred just prior to Macondo. And that Senate hearing was focused on the Outer Continental Shelf exploration and the potential for learning of lessons from Montara. Both industry and the regulator, as well as members of Congress, stated unequivocally that Montara and the experience there was irrelevant, that such an event would never occur. And in fact, certain members of Congress were affronted, they said, by the suggestion by other members that there were issues that needed to be taken care of with regard to this industry. I will just suggest that the term hubris was very appropriate in this particular incident. If I could have the next chart. A one-chart summary, if you will, of what the committee that the National Academies formed said about Macondo. We had a number of major issues that we found in addition to the details of the specific proximate failures. We criticized the lack of a systems approach to safety, looking at the totality of problems that might occur. We looked at the failure to maintain proper margins of safety, and we talked about the multiple failures of decision-making. We talked much about the decision to go ahead and proceed to temporary abandonment in spite of the failed pressure tests. I will note that we found actually a total of 12 additional failures that all increased the likelihood of a significant failure problem. There were obviously issues with safety equipment, and there were, as we talked about in our report, significant limitations evident associated with the prescriptive approach to regulation that's employed in the United States. Lastly, and not the least, I would note that we noted the lack of a supportive safety culture. And I have to tell you that I am one individual that believes very strongly in the need, the essential need for a safety culture. If I could have the next chart, just a little bit about what a safety culture is. First of all, people ask me, what is a culture? And I just assert that culture is what you do when no one tells you what to do. And why is this important? Because no matter how much time and energy we can put into providing prescriptive rules and regulations, we can never anticipate every challenge that will be presented in front of individuals. People need to know, first and foremost, what they should be doing, whether or not it is documented in any form of detail. If you do have a proper safety culture, it helps you understand the priorities and talk about the trades between safety and cost and schedule. And I will tell you that I've heard a number of individuals from this community who have asserted that their organization never compromises safety. I will suggest that's a very dangerous way of looking at the problem. The only way to totally avoid any safety compromises is never to spud a well, never to go offshore, never to start doing anything. The minute you start doing something, you're going to start compromising, if you will, safety. You're taking risks. The question is, are you taking reasonable risks? Are they prudent risks? And should the risks become realized, are you in a position to deal with the consequences of those risk realizations? I will assert that it's often very, very hard to justify spending money or taking time, quite frankly, to avoid what is often viewed as very low probability but high consequence events. The numbers just never work, in part because you never can get reasonable assessments of such low probabilities. And we can get into a long discussion of probabilistic risk analyses, and I will just say that they necessarily represent only a lower bound and never really are in a position to provide an upper bound to the risks. One last thing that I think is very pertinent to this industry is that the trade-offs are not just nicely packaged in such a form that they can be dealt with by senior management. They need to be dealt with by just about everybody involved, from the drilling engineer who's designing the well to the tool pusher on a scene, and through the entire scope of activities from the preparation to bid to the completion of the well. So culture is quite critical. One last case study, if I could, on the next chart, just talk about one example that I can provide with a culture that does seem to be working. And this is something referred to as SubSafe. It is both a process, by the way, and a culture. This is what the US Navy adopted after the loss of Thresher in April of 1963. At that time, we lost 129 souls on that submarine. It was particularly troublesome because this was a brand new design and thought to be of the highest quality in terms of both design and construction. One thing that I think is truly fascinating is the fact that the Navy was able to turn around the experience of Thresher, the very emotional experience of Thresher, and develop SubSafe within that year, literally within months. Now I will stipulate that part of that was due to the experiences with the nuclear propulsion system and similar matters that were similar approaches to managing the risks associated with the nuclear power plant on submarines. So what is SubSafe? I'll just assert very top level that it's a very thorough, very systematic approach to quality. It starts at the very beginning of the design with a series of requirements that are imposed on that design. It carries throughout the entire life of that vessel, from the construction to the maintenance, any modernization activities, the operational aspects throughout all the time that that submarine is in service. Certification, and this is a very critical element, certification is based on only one thing, and that's referred to as objective quality evidence. It's not that somebody thinks it's okay. It's not that somebody believes they have a basis for saying it's adequate. It's because one has very specific objective data that enables one to determine the adequacy of the quality that is being considered at that time. Now, more than just the proscriptive process aspects, SubSafe is a culture. It's a philosophy, it's an attitude, and it permeates the entire submarine community. We have not lost a SubSafe submarine since we started. That's 58 years now. Knock wood here, if you'll permit me. As a point of comparison, if you go back from Thresher 58 years, we lost on average a submarine every 3 years. Now that does not include combat losses. That's in addition to those submarines that were lost in combat, particularly during World War II. If I could have the last chart, please. This is difficult. I do not intend to dismiss the challenge here. What you're about, offshore oil and gas exploration and production, is clearly very challenging. You need to do whatever you can to learn, not only from the major accidents, but also the many near misses. And a proper systematic evaluation of those near misses can provide significant value. I will assert that you need to recognize that regulation can do only so much, and one needs to recognize the limitations. That doesn't mean to stop regulating, but it does mean that one needs to address the gaps in those regulations. And that brings us to safety cultures. And the safety cultures really is what gets you to dealing with those human factors considerations, the vagaries of human behavior that I referred to previously. I will assert that it's difficult to maintain a proper safety culture. You need to have consistency throughout an organization, from the very first level supervision all the way up to the highest levels of management. And communications from all need to be made in a very consistent manner. It's got to be a continuing reminder and a continuing reinvestment. Everybody that works in the submarine community in the US Navy has to be certified for SubSafe. And they get told the story, and they get told that it is their responsibility, their personal responsibility, to make sure that that never occurs again. And once a year, every April 10th, every submarine installation around the world notes and memorializes the Thresher loss. We ring the bell 129 times for those who were lost. We read the names, and in most cases, we have been joined by the families of those who were lost. Fewer direct descendants now, but still, it's a reminder of the criticality of what this is all involved. And as I end here, I just leave you with the question. How should the oil and gas community note and mark April 20th? This is, I will suggest, another opportunity to remind people of what the consequences of safety compromise can be. And with that, I will open up to questions. And Al, I think you're going to moderate this process, correct?
Yes, I am. Thank you, Don. We've had our first pair of questions that are related to one another. And that is, if you consider existing offshore energy sources like oil, for example, and let's say you design a new blowout preventer, what do you do to ensure that the new design or the new installation procedure or whatever will be safe? Or if you look at an entirely new form of offshore energy, now, for example, the proliferation of offshore wind turbines, what do you do to try to get ahead of the game and make sure that you've done things that the new technologies that are inserted are going to have the greatest chance of being successful with respect to safety?
Well, that's really two somewhat separate but somewhat related questions. And I'll just suggest that they both argue for a systems perspective on the problem. One of the challenges that I saw in the blowout preventer qualification process as it existed at the time, and I believe it hasn't changed much since I've been involved, is that all the tests and evaluations were done using static conditions. And why? Because that's really all that could effectively be done, as I was told. But as we saw in Macondo, the problem was that the failure created some very challenging dynamics that precluded the effective operation of the blowout preventer. Being able to get into a closer simulation of the dynamics, the full scope of conditions associated with failures like this, I believe are fairly critical. This is not the only domain where simulating the totality of events is very difficult. We do that all the time in dealing with a satellite qualification for launch. It's very difficult to totally simulate the launch environment, but we do the best we can. We create environments, artificial environments, to put those satellites through. And as such, we're able to do the best we can between the test measurements and the analyses. The analyses anchored or based on the test experience, to be able to get a full assessment and understanding of the margins that exist for safety. I think we need to do a similar approach for offshore wind. What are the potential failure mechanisms there? What are the potential consequences? You can use techniques like bow tie analyses to be able to identify particular mechanisms and recovery mechanisms, dealing with the management of the consequences. But one needs to go into a much more detailed systematic analyses of the overall physical implementation and the particular types of mechanisms that might occur to cause major failures. How might they propagate and the like? Again, these are complex systems and they are likely to fail in complex ways. And just looking at it from a component by component basis is likely to be suboptimal.
So there are a lot of complex systems where there have been failures. You've talked about maritime failures and aviation failures, but we've had failures with nuclear reactors. You yourself have some experiences with Chernobyl, as you and I have talked about. We've had failures with chemical processing plants that have exploded and burned. What are some general guidelines in your mind of how you might learn, at a very high level of system integration? How can, for example, the nuclear folks learn from the oil folks, and how can they learn from somebody whose chemical plant blew up, and so forth?
Well, I think that one of the things that I've tried to put forward today is the value of looking at cases where we forgot the lessons, because I think they give you some view of what you might be forgetting. And so, for example, I talked earlier about the arguments I've heard from some individuals that the adoption of new technologies obviate the need for some of the considerations that were adopted right after certain events. more often than not, we found that the technologies may change the nature and the details of the corrective actions, but do not change the overall approach to the problem. And so I think that looking at safety matters on a multidisciplinary, multi-platform basis can provide some very significant value. And I've tried to develop that thought process as an overall approach to the problem.
So one question that came in and related to something I had in the back of my own mind, Don, is that there, in any industry, there are a series of international standards. And then on top of those, there are national standards, and they're not the same. You know, for example, some of the safety standards, I don't know maritime that well personally, but I know aviation quite well, you know, and I know that US standards for training and et cetera are different than they are in other parts of the world. What are your thoughts about you know, how does the US do relative to others? What can we learn from others? What can the world learn from what you know, a particularly successful country is regulations do, et cetera? How can you sort of globalize the best results and the success stories and the lessons learned?
Well, I think there's a lot to be learned. I thought that what we saw from the Petroleum Safety Agency in Norway and their approach to dealing with safety on the North Sea was very instructive in terms of the value of implementing different approaches to regulation and the safety case approach and the value of that. So I think that there's tremendous value for doing that, looking at different approaches, different cultures of safety that have been implemented on a worldwide basis. I think also we need to be mindful of the fact that the value of a human life varies around the world. I think one of my fascinating experiences was going to a shipyard in India and finding people, well, I was being toured around without ever being offered a safety hat. Rather interesting view of safety in a country like that. I think that the other thing that we need to be mindful of is that many of these systems and most of these companies are multinational in nature. And so whether the US regulatory regime wants to look at it that way, the company needs to look at it from a multinational regulation approach. And so the more that we can do to be able to take advantage of a across-the-board consistency, I think the better it will be, both in terms of providing for safe operation and also for minimizing some of the costs and challenges of various corporations in abiding by those regulations. And that's one of those things that I know is difficult. And in particular, the US legal environment makes this very, very difficult. One of my interesting experiences post our final report was providing a briefing to the ABA, American Bar Association, regarding this. And they have a very different view of culpability and liability and how that relates to compliance with regulations. But it's the way of American legal system.
I wanted to probe a little bit deeper into the notion of cost benefit. We've had a couple of questions around that. You know, I've seen, I'm not going to remember the numbers, but I've seen statistics that say, for example, in the automotive industry, that when the decision was made to install seatbelts, there were so many lives saved for every dollar that was spent on that investment. But then as you go down the safety path, you get to the point where it costs more and more and more for each incremental life that you save. So when you look at a large system like this, I mean, this is now getting really very much involved in, and I guess, the notion of ethics, you know, but how do you frame and think about, you know, the value of an investment that you might make for safety, you know, versus the return of it? If you put yourself out of business or you don't do it at all, you're not going to get to the end point. So how do you put in this balance, ethical balance of safety and cost?
I'm going to start out by challenging the question. I will suggest that virtually every major safety incident that I've been associated with or studied has not been the result of that last little bit of compliance, that most expensive implementation. They almost all tend to be very basic. Yes, in some cases, they would have added to schedule and factors like that. But for the most part, this is not a matter of spending every last dollar. I think that the general guideline of maximum practicable implementation is one that needs to be dealt with. Again, a lot of it depends upon the potential consequences. Is it worth spending billions of dollars to avoid a single life? That's kind of hard to justify, but then again, how sure are you that it's only a single life? How sure are you? The uncertainties associated with those analyses. One of the reasons that I am fairly negative about PRA's, probabilistic risk assessments, is that I find that all too often they really don't assess the likelihood of a failure. Going back to the shuttle, and unfortunately I didn't include that here, with Challenger, one of the points that Richard Feynman made during his participation in the committee that investigated that was that NASA's estimate of the probability of failure was off by several orders of magnitude. And that could be shown just by going to some basic assessments of what the history had been. And yet NASA's probabilistic risk assessment was a stack of paper that was impenetrable, involved so many calculations and analyses that it was impossible to question it, if you will. Feynman did it the other way and basically said, let me look at the history of launches and let me show you how far off your analysis is for even much simpler launch systems than the shuttle. So I'm very cautious, very cynical about some of the probabilistic risk assessments. There are good ones, and I will suggest that the nuclear community has probably done one of the better jobs of that. But I think they must be recognized for what they are, lower bounds. And I think the question basically comes to one of, if it is possible to do something properly, one should. And you can't make that just a matter of dollars and cents.
We've had a question on standardization, and let me amplify it a bit with another study that was done a couple of years ago involving possible oil leaks in the Gulf. But the notion of standardizing equipment, even things down as simple as bolts. There was a study done a couple of years ago looking at failures of bolts just in the undersea piping, where as we dug into it, a number of the people in the committee had backgrounds, for example, in the nuclear or the aerospace world, which, as you know from your also a former life like me, that in the world of aerospace, at least, things are standardized to the ends of the earth, But in the case of what we discovered with, for example, the underwater piping, no one was even sure if it was a grade 6 bolt or who made the thing. There's not a lot of standardization. So, and that's also kind of related to just our discussion on cost. What role do you see on standardization of components, systems, et cetera, in any given industry as a tool to help mitigate and manage risk?
Well, I think, again, it gets down to the question of what are the components that are potentially safety critical. One of the things I really didn't get into with SubSafe is that one of the reasons that it works so well is that it focuses on two very critical questions with submarine. Now, there are many, many safety concerns associated with the submarine. Just think about the galley there and the cooking facilities associated with that. But SubSafe says, let's look at two things. Can a submarine submerge to its proper operating depth without failure? And once it's submerged, can it surface and get back to the surface of the water without question? It's a focus. Again, you go and you try to impose the SubSafe processes on every single element of a submarine, and you'll see some great expenses there. You focus on those things associated with the pressure hull and certain aspects associated with it that you really need to worry about. Similarly, I'll just assert, we don't use the same process for surface ships for similar reasons. The cost, both in terms of financial cost and schedule cost, would just be too onerous and would result in, quite frankly, a much smaller fleet than we could ever afford otherwise. So I think it's a matter of focusing on those areas that are very important. If you can identify those components that really are safety critical and that can be standardized, I think that that's an area that could provide some significant value added.
So if you were the chairman of the board of, say, the company, I think it might be ISO 9000, that's putting the wind turbine field off of the Cape, off of New England. If you were the chairman of the board of that company, what would you be looking for to assure yourself that we wouldn't be bitten by some lapse in systems engineering thinking that led to some safety issue, either for the operators of the turbines or to local boaters or whatever?
Well, I think that first and foremost, one has to identify what the possible risks are. There are many approaches to this. I personally like the bow tie analysis approach to try to look at what the various failure mechanisms might be, what the consequences could be, how one can mitigate the consequences, how one can avoid the circumstances, what are the top events that really relate to those different failure mechanisms. I think with wind turbines, offshore in particular, we have limited history. We need to look internationally because we're not the first to do this. We need to understand what people have experienced and what people worry about. And we need to hear from the other potentially impacted communities. Boating communities, shipping communities, communities associated with undersea pipelines and the like. What are the potential concerns that they have? Because they may have a very different perspective on the problem than you do. Once you get an understanding of the potential concerns, the potential, quote, top events that might precipitate a major problem here, one can then go and take a look at the systems analyses that are available to assess that and understand whether or not one has adequate margins. Again, I'm a very strong believer in the value of designing in and preserving through the entire life of operation adequate margins to guard against failure. All too often, we set those up during the design process and we forget about them. And then 10, 20 years later, we find out we have exceeded those margins and we're having failures. Sometimes that's a minor failure that can be rectified very simply. In other cases, it can be a major safety incident.
Let me take a step beyond that. And I would start by saying that, again, there are some unique things about wind turbines at sea, but we also have a large database of safety events, et cetera, for wind turbines that are on shore. So there's some learnings that are accompanied there. Let's go a step further and say, look at something like tidal energy, where there really, at this point, there is no other surrogate besides tidal energy. We played around with it, but there's not a lot of commercial applications of it yet. So you've got a completely new emerging field. What would you do to try to ensure that you were going to design safety in right from the very start, as opposed to, oops, here's the Band-Aid that I got to put on after the first thing goes wrong?
Well, again, I think it's a matter of trying to identify what might go wrong and what things you need to worry about first and foremost. And I will suggest that getting the broadest possible perspective on the problem is most important here. One of the things I worry about is that people within an industry tend to have a fixed view of what's important. And in areas like tidal energy, obviously ensuring that you're able to do something that's cost effective, that's cost competitive as a power generator has been the be-all, end-all for quite a number of years. But you need a much broader perspective. You need people who are not focused on that particular aspect. You need some people that, quite frankly, you might not even want in your company if you're trying to sell that type of energy. It's kind of like some of the challenge that some of the software companies have, paying hackers, or sometimes referred to as reformed hackers, to try to test their system. And you have to deal with people that you might not like, but it's the type of people that can provide that greater perspective that might prove to identify something that was not otherwise thought of.
You know, I think probably a large number of the people that are listening in here, certainly not all, but a large number of us, you know, are practicing or were practicing engineers. And all of us will recall back in our days as undergraduates, we took some kind of probably more minimal than it should have been course in engineering ethics. There's been a lot of conversation of late around the NAE about where does safety fit into this whole notion of engineering ethics, and where do you, I know one of the things that I saw in my 36 years in industry is a lot of times you'd hire new students, and the first time you let them into a lab or production floor, they'd immediately do something stupid with respect to safety, et cetera. So what do you do to try to make sure right from the start, when a person graduates with that first degree, they're thinking about ethics and safety, not only to individuals that are the workers or nearby, but even to damage to the environment that might often create, you know, a safety issue for the larger public around them, rather than just people that are very close as in terms of workers. But this whole notion of safety and ethics and training of new graduate engineers, especially with this emerging interest in energy, whether it's offshore or onshore, brings with it a whole new raft of questions.
Yeah, it's very much of a challenge. Academic perspectives on safety I find to be often quite wanton. One of the things that I've noted when I've taught my course on safety at Michigan was I tell people it's not going to be an academic perspective. I've had too much direct involvement and experience, and as I said before, some of my absolute worst memories were associated with safety incidents, cases in which innocent bystanders were killed as a result of safety problems with equipment under my purview. It's hard to give students that type of experience, that type of perspective. You get that, though, when you have to go and make a condolence call, when you have to apologize to the surviving members of a family on behalf of the US Navy for the loss of a mother, a grandmother, and 2 infants when an F-18 augured into their residence. Those are experiences that I can never shake. And I tried to explain that to people and tried to tell them that it is my challenge to try to help them avoid those experiences. At the same time, without some experience of that nature, it's hard to really get it sink in. Getting people to see it, to watch it, to understand the consequences. Again, one of the things we try to do within the SubSafe community is to make sure everyone understands that it is their responsibility, and to make sure that they understand that they don't want to listen to see the loss of a submarine that might have been at all the result of what they did or did not do. And that includes not referring to problems, not explaining to management what you see as inadequate, not ringing the bell, so to say, about a problem. So I think it is a real challenge, but I think that a little bit less academic and a little bit more experiential approach to the problem will help.
There's probably a bit of a message in this, Don, because I know anyone who's been around long enough and in the right position You know, getting that call that says, this is the phone call that you never wanted, you know, or when someone's killed, or when you saw that medevac helicopter go by faster than you thought a UH-1 could fly. You know, those are experiences that really touch one's soul. And I'm not exactly sure how you can teach it other than people that have had to experience, you know, I could sense the emotion, you know, in your voice as you told that story. And perhaps you can sense it in mine because it's happened to me. And it's something that's very hard to teach because it becomes very deep and very emotional. But there's some way that psychologists could help us teach that aspect of safety. I think it would be a real game changer.
Agreed.
So we've only got a couple minutes left. And so, see, I've called you Mr. Secretary, but that was when I wanted money. I've called you Don. I've called you Don, but now I'll call you Professor of Practice. Would you like to make any closing comments in the final couple of minutes that we have here, Don?
No, actually, the closing comments I was going to give, I just gave. You know, it's my hope that by giving lectures like this, that I can help some of you avoid the experiences that I've had in the past. And I hope you take it to heart. I hope you learn something from this lecture, as I hope we learn from the previous accidents and near misses in our various industries.
Okay, well, I think then on behalf of the National Academy of Engineering and the Gulf Research Program, and of all the people who are watching, whether they're Academy members or not, I hope that you found this informative and that you learned something and that it made you think about systems and thinking about safety and thinking about sources of energy and things that you can do where the damage can be great at sea, offshore, the Gulf being a great lesson learned. I think this went wonderfully as our inaugural event, Don, and thank you for being willing to step up to the plate and be the very first one to deliver this inaugural lecture. So with that, John or Lauren, any final comments on your part before we pull the plug?
And for me, just a lot of thanks. Thank you so much, Secretary Winter.
Quite welcome.
I don't know, John, are you still there to make any last moment comments? He might have been yanked off to his last one. So on behalf of the NAE, the GRP, and all the listeners and the members, thank you so much, Don.
And just a note for everybody that we will have the recording posted on both the National Academy website as well as the NAE's YouTube channel. Give us a week or two to get that processed and posted. But again, thank you everybody for the gift of your time today. And we look forward to working with everybody in the future. Thank you.